All right, how's it going, everybody? 240, everyone pumped? There's water again, we should be excited. That's an important improvement, yeah. All right, welcome to Decoupled Blocks. I see a few of you here who've already seen this session. You're gonna be really bored. Hopefully there will be something interesting for the rest of you. My name is Matt Davis. I'm a lead architect at MediaCurrent. And there's my contact info. And this is our agenda for the talk today. I'm a little tired, so I may breeze through some of this, but feel free to slow me down if you have any questions as we go. I'm happy to jump in and provide more detail. We're going to start, before we go into really the details of what Decoupled Blocks is, we're going to do a little bit of a history lesson here on sort of the motivations and the model that this Drupal 8 module was born out of. Starting with weather.com. If you did not know, weather.com is a Drupal site. It launched in November of 2014 and has been humming along with varying levels of success ever since. Weather.com as a Drupal site had a lot of very unique things about it. Extremely high traffic. An average day sees about 50 million page views. Extreme variability in traffic. When a major weather event occurs, that spikes from 50 million up to 500, 600 million page views in a day. And also hyper-localization, because people expect to be able to get the weather that's very local to them. So this presents some unique challenges in terms of cacheability and performance and scalability. So here's one example where this was an example they presented to us when they were evaluating Drupal as a possible platform to use. Superstorm Sandy, October 2012. Page views peaked at about 300 million, and they had over 1 billion requests in that single week. And they could not sustain their site. It kept going down. About half of those requests were going all the way to their origin servers. So they had very little caching strategy at all in place. And at that point, they had 144 origin servers. And even those couldn't handle the load that they were getting hit with. So they knew they had a problem. I'm not going to go too much into the performance side of all of this. Decoupled blocks and decoupled panels play a part of a role in that. There's a lot more behind the scenes with Akamai and ESI and things that I won't cover unless people want to ask about it at the end. But we had some unique problems to be solved aside from just that. So one of the big problems that we were catering to is that the weather.com structure, the organizational structure, is they have large teams of front-end developers, mostly JavaScript developers. There's like 40 to 50 of them in the building. And JavaScript developers, what do they want to do? They want to write JavaScript, right? They don't want to have to learn Drupal or care about what a render array is or any of that, all those Drupalisms that we live our lives around. That's not what a pure JavaScript developer wants to concern themselves with. They also want to be able to keep up because JavaScript's changing really, really quickly. Weather.com also has large editorial teams. They're putting out new content all the time. And editorial teams have their own desires. They want to be able to easily and intuitively create new pieces of content. But for the weather team, at least, they wanted not just the ability to create content, but the ability to create whole new pages and layouts of content as well on the fly without having to involve developer teams. So our solution, and the single biggest consideration, again, that had to underlie any solution we proposed was how is it going to perform? How is it going to be scalable to the needs of this site? So how do we approach these problems? Well, first we took a really long, hard look at what we see on a typical weather.com page. So this is a forecast page for some place in Wisconsin for some reason. And as we look at the components, the pieces of this page, we can start to break them down into the different sections, right? So here's a slightly different view. And what we notice I'm switching back and forth between two different cities here, is that a lot of the page actually is the same across cities. So there's specific things that change, but a lot of that could be cached and served to everyone exactly the same. And this is where panels comes in. Panels is really what rescued us from all of these different scenarios. We wanted a way to have different versions of pages, so a single panel page could serve forecasts for everyone in the world. But we can use selection rules to determine, are you looking at this from a mobile device, or are you looking at it from a desktop, things like that, and serve different variants of the page. It also allows editorial teams to come in and drag and drop pieces of functionality onto these pages. So these are panels panes that can be reused and put on pages by editorial teams. So they were trained how to create whole new pages and drop these pieces of content on. And if you're not familiar with it, this is what the back end of the panels UI looks like. And these are individual panels panes that you see here kind of correspond to the regions I showed you earlier on the actual front end of page. So panels solves some of our problems there, right? It really caters to the editorial teams in a way that we knew we wanted to leverage. But what about the front-end developers, and what about these caching concerns? And that is where the headless piece comes in, right? There's been a lot of hype around this headless model. In a purely headless scenario, what we're really talking about is completely removing Drupal from rendering the page at all, right? So in a fully headless model, all Drupal is data content and data store, and then whatever rendering layer you would have would pull just the data in maybe JSON or XML format to use, and then build all the markup themselves as a completely separate layer. So there's some gains that you can get from going fully decoupled or fully headless. You get a lot of flexibility. Once you have both sides operating completely independently, you could upgrade either one. So in a fully headless model, you could upgrade your entire backend from Drupal 7 to Drupal 8, make sure the data is coming out the same way, and without ever even touching the rendering side. And this kind of flexibility allows for a richer user experience, because at the same time, you could leave your data layer exactly the same and completely upgrade your rendering layer to whatever the new hot JavaScript framework or whatever is. So that really gives you a lot more flexibility. There's also this idea of create once and publish everywhere. So in a fully headless model, you're using Drupal as this data store, and you have these JSON endpoints, for example, but those don't only have to be accessed by your main website. You could use those same data endpoints for your mobile app, or for your IoT device, or for a myriad of for RSS feeds, or whatever you want. So you can reuse the same, create an article once, and have it published to a bunch of different places, because they're all consuming a single RESTful endpoint. But when you go fully headless, you create some new problems for yourself. Or really what you do is you have to re-solve problems that Drupal has already solved for you. So in a fully headless model, well, you can't use panels, because panels, you would have to completely recreate how are you going to lay out these pages. There can be some performance concerns as well if you don't have strong guardrails in place for your rendering layer. Redirects and aliasing, something that Drupal does really well. Panels does really well. Using the variant system, you can have URL parity across different versions of the same page. That's a problem you have to solve again in a fully decoupled world. SEO, meta tags is a really powerful tool with Drupal, where you can define content-specific, page-specific, or global meta tags, and all of that gets aggregated out and figured out which takes priority in very smart ways. You got to resolve all that if you move Drupal out of the way. Multilingual also is another one that's not on here. But a lot of it comes down to structure, right? Because Drupal is a framework that imposes a very specific structure on how things are going to be rendered. And if you completely remove that, you have to rely on a front-end team that is going to impose their own new structure and adhere to that. So we didn't want to go fully headless. So we built what at the time was called the presentation framework, or I may refer to it as decoupled panels as we move forward. The idea behind this was to give their front-end developers, their JavaScript developers, access to as much of Drupal's power as possible without them having to worry about all the details of everything it's doing. And I'll explain exactly what that means. At its core, what the presentation framework does is it allows these front-end developers to create pieces of JavaScript functionality that are turned into panels panes. So without having to write any Drupal at all, they create these little compartmentalized pieces of functionality which are then able to be placed by their editorial teams as panels panes onto Drupal pages. And when this originally launched with weather.com, it was specifically supporting Angular 1 was what was mainly being used. And we also supported static templates as well as tipple fips. And allowed them, again, I'm not going to go too much into the ESI side, but you could serve those as either Drupal rendered or ESI rendered panels panes. And so another gain of this that I'll show you in the code side in a minute, these individual compartmentalized Angular mods or presentation framework modules can be reused, they can be exported, they live in code, so it's easy to push them through deployment cycles, and they're versioned as well, so you can have requirements on specific versions. So here's an example of what an individual Angular mod or Angular component looks like. This is for the 24-hour forecast. And as you see, it has its own little directory. It's very compartmentalized along the kind of components discussions that happened. There were 2 different sessions on similar lines earlier this morning in this room. And what you see here is that it's got all the CSS and Sass assets that it needs, all the JavaScript that it needs, as well as the template, all in one place. Now the piece down here, this is what really brings it all together, this .info file. And this is just a small JSON structured file full of metadata about this component that declares it out to Drupal. So what the Drupal presentation framework does is it walks all these directories and looks for these info files. And for each one that it finds, it turns those into panels panes that Panels is aware of. So that forecast, 24-hour forecast module you see here becomes the forecast module that you can place on a page as a panel pane. And I'm not going to go into all the details of this, but the part I want you to notice here is that what we have is the most cacheable and reusable pieces of the Drupal page, what you see down here, that's what's served by Drupal, right? And that goes out to every single visitor that looks at weather.com exactly the same. And that means it can be cached all the way out from origin, all the way out to Akamai, exactly the same for everyone. And then once you're looking at the weather.com page, we use Angular to fill in the pieces that have to be, that have low cacheability or need to be hyper-localized. So these 2 different pages are just filling in the bits that need to be more specific. So we built this whole framework, and one of the big ideas was to just be able to let these JavaScript developers just run as fast as they could with this and not have to come back to us every time that they needed some new feature. But we didn't really know in advance how well they were going to use this. So we built this, set them loose. There are 40 to 50 JavaScript developers. And within a few months, they had built hundreds of these things. Without having to bug us. We couldn't even keep track of all the different things they were doing with these. Yeah, now there's over 200 of them as of today on weather.com. So all of that is kind of ancient history at this point, because that site launched in 2014. More recently, as of last November, I began working really closely with Weather Underground. They're a sister site of weather.com. They're both owned by the Weather Company. And they were being brought on to the same Drupal platform that we had built for weather.com. But Weather Underground likes to be a little more experimental. They're kind of a smaller, more agile shop. And one of their first questions when I went out there doing discovery on this migration was, why would we use Angular 1 when Angular 2 is already far into beta? Like, we want to explore the option of using Angular 2 instead. The problem there is that they live in the exact same code base. And the presentation framework we had built was tightly coupled to Angular 1. So I spent 2 months figuring out how we were going to make this work with not only Angular 1, but Angular 2 as well. And this is, if you don't know that much about Angular, Angular 2 is a complete rewrite from the ground up, like Drupal 8 to Drupal 7. There's no intercompatibility there at all. So it was basically completely making it framework agnostic is what had to happen, while not breaking weather.com with any change that we made. In some ways, Angular 2 is actually a better fit for this kind of system that we had built. It's component-based by default, so this sort of compartmentalization that we had enforced on the Angular 1 developers, that's a very natural thing in Angular 2. And it also has lazy loading of components on demand built right into it. Lazy loading solution for Angular 1 was something we really struggled with a lot. In other ways, it was not so much of a better fit. It was very convoluted to try to make it so that we could reuse Angular 2 components, because the first thing you do in an Angular 2 component is declare a specific selector. And if you had 2 of that same selector on the page, it's just going to bootstrap the first one over and over. So we had to work directly with the Angular team to figure out how to do some things as well. So as of right now, today, Weather Underground is still going through this slow progression of migrating onto this Angular 2 Drupal platform. They're currently running release candidate 2 of Angular. We started in beta 17, I think, is what we launched on. And release candidate 5 just came out this week, so we've got a bunch of work ahead of us as well. But that is all happening in a Drupal 7 world. So what does all this look like in Drupal 8? Well, that's where you can throw the panels piece of this out the window and say hello to decoupled blocks. Why? Because blocks aren't terrible anymore in Drupal 8. Blocks can be exported to code. They can be reused. A lot of the problems that existed in blocks and the reason that many people didn't use them at all in Drupal 7 have been solved. And as a matter of fact, panels in Drupal 8 is built on top of blocks and uses blocks as well. So that means that decoupled blocks can also be placed through the panels UI just as easily. A lot of other improvements in Drupal 8 that we leverage a lot, the new plugins API, the new libraries API. We don't use it directly, but it's super easy to hook your components into the new RESTful API that Drupal 8 includes. And also, we're really excited about a lot of the hype that GraphQL has been getting and are hopeful for its eventual inclusion in Drupal core as a way to really dynamically query the back end from your components on the front end. A lot of the work that I've done on the Decoupled Blocks module, it is a JavaScript framework-agnostic module. So it is built, unlike what happened with weather.com and Weather Underground, where we had to refactor underneath the 40-story building to make it work with multiple frameworks. Decoupled Blocks is built from the ground up with the idea in mind that you can use whatever JavaScript framework you want with it. That means each framework has its own little submodule where it does its framework-specific logic. And right now, there's an Angular 2 one, there's a small React one, and there's some work being done on an Ember submodule as well. But whatever comes out next, whatever the next hot new JavaScript framework is, it should be relatively easy to hook it into this and build its own submodule as well. Most of my work on decoupled blocks on the JavaScript side has been on the Angular 2 piece, just because that's what I've been getting paid to learn and work with anyway. So the Angular 2 piece right now is pretty fleshed out. The React is very small at this point. You'll hear from Tommy right after me. Hopefully he's made some good improvements to it. And a little bit about the Angular 2 piece. Right now, Decoupled Blocks is on release candidate 3 of Angular 2. Like I said, RC5 just came out this week. It's got lazy loading baked into it automatically. So when you place Angular 2 blocks, it actually does viewport detection and only loads components that are visible in your viewport. It's written in TypeScript and has gulp tasks built into it so that you can compile your TypeScript to JavaScript. And there's also a fancy thing called offline template compiling that sort of works. It's an experimental feature at this point. RC5 just completely changed how it's architected too. I already mentioned this, yep. Other frameworks are coming if you build them. So there are some hard problems left to solve with decoupled blocks. Dependency management is a big one. One of the ideas we have here is not just that you can create these JavaScript components without having to learn a bunch of Drupal, but also in theory that you could grab an Angular 2 component that you found somewhere out on the internet, and just by writing a small metadata file, we're using YAML now instead of JSON, but just by writing that and putting it in a directory in your Drupal site, Drupal would recognize it as a block that you could place onto pages. Where that gets complicated is when the component that you find somewhere has a specific dependency on a specific version of whatever, which may conflict with other things that could already be on your site. So we're looking into ways to recursively go through package.json files to build like a full dependency tree for your entire site and not just for specific components. Bundling is another hard problem that we deal with because editorial teams are the ones that get to make the decision about which components go on pages, and because those components can be reused, but we can't know in advance which components are going to be on any specific page. So in a typical, if you were building an Angular 2 app from scratch without this Drupal decoupled piece, you could know exactly which components would be on any given page and feed those into Rollup.js or Webpack or whatever tool you're using for bundling, and have it create really smart bundles based on what it sees on pages. But that's a lot more complicated with decoupled blocks because we can't know in advance what those are going to be. And one of the things that I'm eager to see come about, it's not really so much a hard problem as something I'm excited about, is as other frameworks get built out, to find common problems across frameworks that we can pull back out into raw JavaScript or PHP solutions that we can use across them. There's already a couple examples of that that I can show you. So, live demo time. I will show a little bit of code first, actually, because that was a whole lot of talking. Let me kick this into presentation mode. Okay. So what you have here is the PDB. PDB stands for Progressively Decoupled Blocks. That's also the namespace. You'll find it on Drupal.org. The main decoupled blocks module here. Some of the cool stuff you'll see in the main module. Component discovery. So because we're using YAML files now, we are leveraging the exact same discovery mechanism built into Drupal 8 core that is used for finding modules, for finding themes, for finding profiles. The only difference is that we've made a new type, which is PDB. So this exists on the same kind of hierarchical level as a module or a theme or a profile. And we're leveraging that exact same discovery mechanism instead of having to write our own, which is what we had to do for weather. So let me show you a little bit about how these components look. I'll show you the one I'm actually going to showcase. So this is an example Angular 2 component. And we have its little info.yml file. And this is all it takes to make this component visible to Drupal. By giving the type PDB, Drupal knows that this is a decoupled block and will turn this into a block that you can place on a page. So let me show you what that looks like. I'm just using the core block layout for this demo, but like I said, you could do this just as easily with the panels UI or whatever other block UI comes along. And here among the regular blocks, you will see these PDB Angular 2 blocks. So I'm going to place this to-do list block and save it. Move it up to the top here. And there's our Angular 2 component on the page. Put real words in here. So I can cross that one off. So that's just an example of some of the kind of rich feature, like that little thing. It's not even that impressive, but it can spark your imagination as you can't do that in Drupal that easily. But you can write this Angular 2 component without having to know any Drupal now and have a much richer experience for your users just by hooking that in and dropping it onto a page. Some other cool features that I will show you. You can actually have instance configurations. So we have an example component in here, and you'll see in the info.yml file, you can add configuration fields. So this is basically like a YAML version of the Drupal Forms API. And because these components can be reused, you may want slightly different data or different versions of these components for each instance. So here you say, I want, when someone is placing this block on a page, I want that editor to be presented with a text field and that specific data to come through. So I'll show you what that looks like too. So that text field that we saw there with the example hello world default text, we can replace it at block placement time. Move that up to the top. And our customized instance data is available to our component. It's also available inside of Drupal settings, so you can do whatever you want with it from there. You have it in a global window object, accessible across the whole page. One other cool thing is we have the ability to do entity. You can actually define an entity context. So for this component in Angular 2, we've said this component should only show up when we have an entity context on the page. If there's no entity context, it will not be displayed at all. If there is an entity context, the entire node object will be passed forward so that the component has access to all of the data inside of that entity. So that's really just a few different things to hopefully inspire a little ideas about what could be possible here. And that's it. Any questions? Yeah. In the Drupal 7 version. So in the weather.com, Weather Underground world, they have their own separate services layer. It's a Mongo database. So we push all the Drupal data out to this Mongo database. But it's the same idea as like in Drupal 8, you could create a RESTful view that output JSON. So they can make HTTP calls to these services. That's one way to do it. There's also this idea of we can pass forward information automatically, kind of like I just showed you with the instance configuration or the entity context. In the panels version of this, we have panels context. So that's what a location is, for example. On weather.com, when you put the zip code at the end, that's turned into a panels context. And that's passed automatically through Drupal settings to the Angular mods. So they have access to that without needing to make an extra request. Anybody else? Sure, yeah. You have a specific question, or? Absolutely. I can go a little bit into more detail. Actually, let me go back a couple slides, because that is the other piece that really makes this all work in the performant and scalable way. So this is the kind of mocked up rendition of a forecast page on weather.com. And what we actually do at the Akamai level, when we receive a request that has this weather/today prefix in it, is we slice all of that off. So everything, all the zip code, the localized information, we remove that from the request and send just a single, so regardless of where you're coming from, you go one request back to origin. And instead, we store that, the zip code, the localized information, as an ESI variable. Now what ESI is, you can think of it as like edge computations. So in traditional web development, you have like two places you can do work, on the server or on the client, right? Now, Akamai is a content delivery network. That means we have our origin servers, and then we have servers all over the world that are sitting as close to the end user as possible. And then they have their machine that they're actually looking at the site on. So there's actually a third place you can do work. Instead of doing it at the origin server or on the client, the actual user's computer, you do it at the edge instead. And that means you're doing more computations closer to them that are relevant not to a specific user, but to whoever's in Asheville would get the same computation done. So it's more efficient when you have that third layer that comes in between. It saves us a lot of requests back to origin, and it saves work having to be done over and over on every single user that could actually be regionalized. So that's the idea behind how we leverage ESI. And in practice, what we do is, we lop off any localized stuff. That's a zip code, so it's not personal, but it's localized, right? Lop that off, single request back to origin that serves that basic wrapper template that I showed you that's the same for everybody. And then ESI adds back in the pieces that are region or local specific. That's the basic theory behind it. Did that make sense? I'm doing a whole session on ESI, so I'll be going into a lot more depth about it at DrupalCon Dublin next month. No other questions? All right, thank you.